Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 5-8 Extra Practice Number 1 solutions on simple trigonometric equations. For this problem, we're trying to solve for all values of theta between 0 and 360 for this trig equation. We're going to start by isolating cosecant of theta. So we add 9 over here and divide by 6. But there's no cosecant button on the calculator, let alone an inverse one. So we're going to take the reciprocal of both sides. That makes the left side into sine of theta, and the right side into 6 over 9. And now we can figure out which quadrants we're in. Sine is the y values, and this is a positive value, 6/9. So that means that we are above the x-axis in quadrants 1 and 2. Let's go ahead now and take inverse sine of 6/9. So sine inverse 6/9, and let me just make sure I'm in degrees mode. There we go. That's going to give us 41.8 degrees. That is a reference angle, so we're ready to go with reference angles. So now for quadrant 1, we actually already have our answer of 41.8 degrees. For quadrant 2, we need to do 180 minus our reference angle of 41.8. Let me do that on the calculator. And that's going to give us 138.2 degrees. On this problem, we're trying to solve the equation 5 secant of theta minus 6 equals 0 to the nearest tenth of a degree for all angles between 0 and 360. Let's start by isolating our trig function here, the secant function. So we can do that by adding 6 to the other side and dividing by 5. So that's 6 over 5 that secant equals. Now there is no inverse secant button on your calculator. We need to express this as one of the original 3 trig functions. Secant is the reciprocal of cosine. So I can rewrite this as cosine of theta equals the reciprocal over here, 5 over 6. And I notice at this point that we have a positive value of cosine. That means that I'm going to be on the right side of the y-axis in quadrants 1 and 4. So let's go ahead and do inverse cosine now of 5 over 6 to get that first angle. So doing this on the calculator, it's going to come out to about 33.6 degrees. Now this happens to be a reference angle, which we'll make note of here, because we're going to need this to get all of the angles in these quadrants. For quadrant 1, we actually already happen to have a quadrant 1 angle between 0 and 90. So this angle is helping us out a lot, and then we'll find the quadrant 4 angle in just a sec. So quadrant 1, 33.6 is our angle. For quadrant 4, we have to go 33.6 degrees away from the x-axis into quadrant 4. So starting at 360, we're going backwards 33.6. We're doing 360 minus 33.6. And let's see here. That's going to come out to 326.4 degrees. There we go. For those of you who are tired of using the calculator, this problem is for you. So to solve this one, we need to isolate our cosecant function first. To do that, we subtract 4. That'll give us 4 on the right side. And then we divide by -4. So we have cosecant of theta equals -1. Now we don't have an inverse cosecant button, but we do have a sine button that we can take the inverse of. So we just need to write the reciprocal of both sides here. Reciprocal of cosecant is, of course, sine of theta. Reciprocal of -1 is also -1. And then if we're asking where the sine of theta equals -1, at what angle do we have an output of -1? Well, that's y values, and that's going to be the y value at the bottom of the unit circle. So that has to be the y value 270. And that is going to be our only answer. There's only one place on the unit circle where you get a y value of -1. For this problem, they want us to solve this trig equation in radians. We're going to start by solving in degrees, and then we'll convert to radians at the very end. So I already have tan isolated. I notice that tan is negative. That means that I want the quadrants where I have a negative slope for the angle, which would be quadrants 2 and 4. So let's get a inverse tan of this to figure out what the starting angle is going to be. So tan inverse of -1.5. So now doing this in degrees mode, I end up with -56.3 degrees. And the reference angle on that is just going to be positive 56.3, because that's how far we are from the x-axis. And now I'm going to use this reference angle to get quadrant 2 and 4 angles. So for quadrant 2, I have to do 180 minus this, which I'll do on the calculator. So that's going to come out to 123.7 degrees. For quadrant 4, I need to do 360 minus the reference angle 56.3. And that's going to come out to 303.7 degrees. Bam. All right. So I've got my angles in degrees, but I needed them in radians. So now I need to multiply each of these by pi over 180 degrees in order to convert. So we'll do the first one here on the calculator. So to do this, I just used my alpha y equals to get this fancy fraction format. And I also did second exponent button to get pi. So that comes out to 2.16 radians. And next I'll do 303.7 times pi over 180 on the calculator. And I'm just going to go up and grab my input from before, because it's almost what I need. I'm just going to replace the degrees angle here with 303.7. And now press enter. We get 5.30 radians. For this problem, I'm trying to solve this trigonometric equation between 0 and 2 pi, so I have to do this in radians, nearest hundredth of a radian. I'm going to solve it first in degrees, and then I'll convert to radians after. So to start this, let me start by isolating the cotan function. I can do that by subtracting 2 and dividing by negative 4. So if I subtract 2, that's going to be negative 12.04. And dividing that by negative 4, let's see here. If this is 12.04, dividing that by 4, that's going to be 3.01. So positive 3.01 equals cotan of theta. And I don't have a cotan button on the calculator or an inverse cotan button, but I do have a tan button, and cotan is the reciprocal of tan. So if I turn this into tan by taking the reciprocal, I just have to reciprocal the other side here. So I can rewrite this as tan of theta equals 1 over 3.01, which is kind of weird to see in a fraction, but we're just going to roll with it here. So I note at this point that tan has a positive value. That means I must be in the quadrants where the slope is positive, quadrants 1 and 3. So those are the quadrants I'm going to look for my answers in. Let me now take the inverse tan of 1 over 3.01, and let's see what that comes up with on our calculator. Now, it's important to note before I press the enter button here that although, again, we are solving for this in radians, I'm initially solving for this on my calculator in degrees because I find everything is easier to do in terms of which quadrant I'm in and reference angles and everything else in degrees. So pressing enter, we get 18.4 degrees. And that happens to be a reference angle, so I can use that to help me get my other quadrant. So now let me figure out quadrants 1 and 3. So quadrant 1, we actually already have that. That's 18.4 degrees, which we will convert to radians in just a little bit. Quadrant 3, well, I've got a reference angle of 18.4. So that means that I'm 18.4 degrees away from the x-axis in quadrant 3, which means I have to go 18.4 past the 180 line to get into quadrant 3. So 180 plus 18.4, which I don't need a calculator for that. That's 198.4. But now I need a calculator because I'm going to convert these to radians, and it's not going to come out to a nice, neat number with a pi in it. So to convert each of these, I multiply them by pi over 180. So let's do that for this quadrant 1 answer first. So here we go. 18.4 times pi over 180 gives me about 0.32 if I round that to the nearest hundredth. And now same thing over here, multiply by pi over 180. Going back to the calculator, I'm going to yank this input from earlier. And let's see, I want 198.4 times pi divided by 180. So I'm going to be a little bit sneaky, and I'm just going to second delete, insert a 9 in here. So this is going to come out to about 3.46. For this problem, we're trying to solve for all answers between 0 and 2 pi to this trigonometric equation. So let's go ahead and isolate our trig function to start this off. I can do that by adding 5 to the other side. That'll give me negative 2. And if I divide that by negative 4, I have 1/2 over there. So if cosine is 1/2, the important thing to note at this point before we go any further is cosine is positive, which means we're on the right half of the y-axis, which means we're in quadrants 1 and 4 for our answers. So let's go ahead now and take inverse cosine of 1/2 and see what we get. So you could do this on the calculator. You could also ask, what do I have to take the cosine of to get 1/2? If you know your special angles pretty well, you might remember that you need the cosine of 60 degrees to get 1/2. So 60 degrees is our initial answer that our calculator would give us. That is a reference angle right off the bat, so that's kind of nice. Now we have to get our two answers in quadrants 1 and 4. For quadrant 1, we already have that answer. It's 60. It's between 0 and 90, so we're good to go there. We will have to convert it to radians later on, but I'll cross that bridge when I get there. Let me get my other angle now, quadrant 4 angle. So that's going to be 360 minus 60. We're going backwards from 360 into quadrant 4. We're 60 away from the x-axis in quadrant 4. So 360 minus 60 is going to be 300 degrees for that one. And now I'm going to multiply each of these by pi over 180 to get an answer in radians. Now they said 100th of a radian, but I mean if you can give exact value with a pi in it, that's even better. So multiplying by pi over 180, this is going to reduce to pi over 3 for my quadrant 1 answer. And down here, quadrant 4, these can be reduced by 60. This is going to be 5 pi over 3 for that answer.